games and play are well established as educational tools for STEM topics. Over the past 2 decades or so, game-based learning has become increasingly popular in computer science education. It's been shown to support learners in developing both their programming skills and their computational thinking, the ability to frame human problems in terms of how computing can be used to solve them. This question of how to apply computing to human problems is an ongoing one, especially for new, emerging computing paradigms. Quantum computing is one such paradigm. It's a way of using quantum mechanical principles, the physics of very small particles, to solve certain types of complex problems. And these certain problems are often very difficult or even impossible to solve using the computers we have today. However, there's some obstacles on the road to this quantum future. One of them is a growing labour gap, a lack of people with the right knowledge to help build quantum computing systems. And in particular, people with computer science knowledge, with programming and computational thinking skills, but also with intuitions for how quantum aspects manifest in these skills, what intersects and what differs. In other words, people who can identify human problems where quantum computing could be helpful, and implement this technology through code. I mentioned earlier that games and play are effective ways of building these kinds of skills, and quantum computing educators recognise this value too. There's been a number of educational games developed in recent years to introduce quantum computing to broader audiences. But a lot of these games are looking at the physics that powers quantum computing, rather than what the computing actually entails. So, for someone with a computing background, this isn't likely to help them build those quantum-aware skills that the burgeoning quantum computing industry is searching for. And this problem, or really this opportunity, is at the core of my research. I'm asking how games and play could support computing-centered skills and intuitions in the quantum computing context. What kinds of concepts are important to learn about here? How they could be represented to emphasize their computational role and encourage playful interactions? How game mechanics could structure and contextualize these interactions? And whether all of this actually supports computing-centered learning. So far, I've worked with quantum computing experts to determine which concepts are relevant for computer science, and assess the quality of existing representations we use to communicate them. From this, I've proposed some design guidelines for how to make more computing-focused and playful representations. I'm now putting these guidelines into action in a research-through design process where I'm creating audiovisual prototypes to test with learners with a computing background. With this work, I'm hoping to show the value of play and of HCI in making quantum computing both more accessible and more useful.